13.6 Rotations and Symmetry. A rotation can be thought of as a turn. In a circle there are 360 degrees. This would be a full turn. In a half circle there are 180 degrees. This would be a half turn. In a quarter circle there are 90 degrees. In general, rotations are always made in the counterclockwise direction, which means we're going to the left. Counterclockwise is going to the left. So if I tell you to do a 90-degree rotation, you should assume that I want you to rotate the figure in a counterclockwise direction about the origin. And that phrase, about the origin, means with respect to the origin. We're rotating it around the origin. Alright, let's look at a few examples on how some rotations would work. And when you do this yourself, you would be using a protractor, and the steps are such that I would have to teach you in person. But for now, you get to see what it's all about. This is the pre-image, okay? This is the image, and it has undergone a 90-degree rotation. So that means that we start with the pre-image, and we rotate it counterclockwise. This here is a 90-degree counterclockwise rotation. Let's look at this 180-degree rotation. So my pre-image is this red dot right here, meaning this is where I'm starting, and I need to rotate it 180 degrees. One thing about 180-degree rotations is that clockwise, counterclockwise, either way it's going to end up in the same location. But we would do this for counterclockwise, and so would rotate this way. This would represent a 180-degree rotation. And then let's say that we start with this green dot right here. This will be the pre-image, and I would want you to rotate it all the way. This would be a 270-degree counterclockwise rotation. Alright, always assume that the origin is the center of rotation unless you're otherwise told. That's what this black center dot right there would represent, the origin. Always assume that the center of rotation is the origin unless you're otherwise told. So we're going to plot this coordinate 5, -7, in the coordinate plane. Then we're going to conduct various rotations on it. There's always a rule for our transformations. So see if we can figure this out together. First thing, coordinate 5, -7, this would be our pre-image. If we're going to rotate this point 90 degrees with respect to the origin, around the origin, again, as I said, that if you're not specifically told, you assume that you're doing a counterclockwise rotation, meaning to the left. What quadrant do you think that it'll end up in? Hopefully you're thinking that it'll end up in the first quadrant. It will. And let me just remind you about a couple of things. So this is the first quadrant, and the signs here for coordinates are always going to be plus plus. So this point here is going to rotate 90 degrees. It's going to end up right in the next quadrant. Okay, so you know that it's going to end up in this quadrant, but you're like, okay, where? Well, alright. So let's look at possible coordinates that involve 5s and 7s. In this particular quadrant, we know that there is one coordinate of 5, 7, right? So let's look and see. There's 5, 7, right? So it could end up here, okay? Or it could be coordinate 7, 5. So coordinate 7, 5. How can you tell? Well, and eventually we will get to the rule, but sorry, I'm not good drawing straight lines by hand. You want to see which point forms a 90-degree angle with the original. And again, it's just a little bit off. Which one? Now this right here is a 90-degree angle. You might have to turn your head a little bit. This is a 90-degree angle. And which point does it look like forms a 90-degree angle with the pre-image? Looks like coordinate 7, 5 does the trick. So, quadrant 1, which we know is plus plus. The image is located after that 90-degree rotation at coordinate 7, 5. So now let's go ahead, go back to the pre-image, and we're now going to rotate it 180 degrees about the origin. So if it's rotating 180 degrees, what quadrant do you think it's going to land in? Remember, we're starting from the pre-image and we're rotating 180 degrees. Hopefully you're thinking that it's going to end up in quadrant 2. So let's take a look. Okay, so in quadrant 2, the coordinates are going to be negative and then positive. Okay, so it's going to always involve the exact same numbers when we're rotating with respect to the origin. So let's look at two possible coordinates that have 5 and 7 in the second quadrant. One would be -5 and +7. Okay, another possibility would be -7 and +5. Okay, so when you're trying to determine, okay, which point could it be, remember that the pre-image was here. We need to find the coordinate that forms a 180 degree angle with our pre-image. A straight angle is an angle that measures 180 degrees, and if you recall, it is a straight line. So, okay, so a straight line through going right to our pre-image, again, this angle here measures 180 degrees. This is 180 degrees. Look at the angle that it points to. That's our angle. So, coordinate -5, 7. Okay, so now for the last part, we're going to rotate it 270 degrees with respect to the origin and state the coordinates. Let's see. Okay, so we're rotating it 270 degrees. If we were rotating it 90, it would be in quadrant 1, 180, quadrant 2, 270. It's going to come all the way into the third quadrant. And so quadrant 3, the signs are negative, negative. So we need to find two possible coordinates in the third quadrant that could possibly be our image. So again, the numbers will be the same. So one possibility would be -5, -7, and then the other one would be -7, -5. Okay, so I think here's the shortcut way of doing it. Now, because these two are so much closer, it's easier for me to go right to compare quadrant 1 to quadrant 4. Now, for rotating from this quadrant to this quadrant, we needed them to form a 90 degree angle. Going from this quadrant to this quadrant, we needed them to form a 180 degree angle. Going from this pre-image all the way around, yes, we do need them to form an angle of 270 degrees, but we don't have a protractor right now. So how would we do it? Keep in mind that 270 degrees is 360 minus 90. So we need to see which angle forms a 90 degree angle with the pre-image. So now some of this, of course, is due to my own human error, not drawing my lines perfectly, but what we should discover is if we drew this line directly so that it's going directly through the center of this box and so forth, it would have hit this particular coordinate. So coordinate -7, -5 is our coordinate. So quadrant 3. Okay, so notice a pattern. The pattern will help you to figure out a rule. There is a rule anytime we are rotating 90 degrees or rotating 180 degrees or 270. Let's see if we can do that really quickly. You start with XY. So notice that the X and the Y coordinates switch places and the value of the Y is opposite, -YX. For 180 degree, what happened is that they switch places, X and Y switch places, and the signs are different on both. And then lastly, when we look at the 270 rotation, okay, looks like Y changes places, but it's not an opposite, so Y comes here. But look at what X does. X changes places, but it is an opposite, so it would be Y and -X. So here could be some simple rules that we could use to do some rotations. So we're going to now rotate this triangle 90 degrees about the origin, graph the image. So what I'm going to do is start by labeling the vertices of the figure, list the coordinates, And then using one of the rules, I'm going to use the rule for a 90-degree rotation. I'm going to find the coordinates and just plot the points of the image. Do it that way. And then I'll do the exact same thing for the other problems. Okay, so let's see what we get. Okay, again, freehand. You get the idea though. Alright, so this figure has been rotated 90 degrees counterclockwise. Okay. Okay, so sorry about the. Hopefully, you did correct the error. I put a little bubble to correct the error for the 180-degree rotation rule. But there we go. It's been rotated 180 degrees. Straight line through the origin for each one of them. I think actually I would like to see you do this one by yourself. You have the rule. Let's go ahead and label these points right now. I actually happen to be hungry, so I'm going to allow myself to be influenced by that. Alright, so what I'd like you to do is to provide me with the coordinates of your pre-image, and then of course provide me with the coordinates of your image after you've used the rule to demonstrate a 270-degree rotation. Okay, and that's it. Have a good evening.